So this is another example of a prism, and you can see how the top and the bottom here are two surfaces that are identical and parallel, right? Identical and parallel. So whenever you have to find or identify a base of a prism, you look for two surfaces that are identical and parallel, right? So here, this top is the base and this bottom is also a base. What shape are the bases? They're hexagons, right? The base is a hexagon. That means this is a hexagonal prism, okay? So again, the bases are congruent polygons and they're parallel to each other. The faces on the sides that connect the two bases, these are called lateral faces. Okay, that term is important, lateral. The lateral faces intersect at the lateral edges. So for example, you know, like these here are the lateral edges. And they're also going to be parallel. Yeah.
Is it okay for those sides to be like different if one longer?
The lateral sides? No, because I mean, like, oh, the faces?
Yeah.
The faces, yes, as long as they're all parallel.
All right.
Okay, here we go. The height. Okay, this is important because often students always think the height is vertical. Not necessarily, right? Because if I take something and if I lie it on its side, then it changes, right? So the best way to find the height is it's actually the distance between the bases, right? So if I took this and if it was lying on its side, that will be the height, the distance between the two bases. And then the lateral area is the sum of all the areas of the lateral faces. So you see the lateral faces here. What shape are the lateral faces? They're rectangles. The areas, the cumulative areas of all of those is the lateral area. Okay, so first of all, how do you find surface area? Imagine this was your shape that you wanted to find the area of. And imagine you had to gift wrap this, right? But you have like very little gift wrap paper left, and you want to like conserve as much as possible. So you know how like when you normally gift wrap, like there's a lot of like overlapping that happens. Suppose you don't have enough to do that. You're just gonna cut out literally enough to just cover the surfaces here. And then here, you know, like you'll cut out a little bit and like you'll paste it on the top and the bottom, right? At the end of the day, when you take all of that paper that you cut up to cover this exactly without any overlaps, the area of that paper is the surface area of this, okay? All right, so how am I gonna find the surface area of this? First, you have to identify what shape this is. These are the bases and they're hexagons. So this is a hexagonal prism. That's gonna determine how you go about this. Okay, so the surface area is equal to what? First of all, if this is a regular hexagon, I know how to find the area of that, right? It's half times apothem times perimeter, right? I call the area of the base capital B, okay? This is where it's really important for you to use your capital and lower cases properly. How many of those base areas do we have? 2. So it's 2 times B, okay? That's the area of the...
Could you try?
No, that wasn't. This is the area of the base. So it's 2 of those plus, now we have to find the area of each of these shapes. So first of all, this one here, what's the area? A times H, correct? Plus, what's this next surface area? What's the area of this surface? B times H, plus the next one is C times H, D times H, E times H, plus F times H. 2B. SA equals 2B. Okay? This, okay, this is actually called, you know how like these were the lateral edges? This is the lateral surface area. Okay? That's called the lateral surface area, just the sides. Huh? Same. Okay. So surface area is now equal to 2b plus, can we factor out an h from this blue part? And I get h times a plus b plus c plus d plus e plus f. Yes. So this is 2b plus. Okay. This, right? Look. A plus b plus c plus d plus e plus f is the perimeter of the what? The base. So this is now the perimeter of the base. I call that P times H. So that is the surface area of a prism. Okay? You're never going to do this like this again. You're always just going to memorize the formula and do it. So remember, it's 2b plus the perimeter of the base times the height. Yeah.
Oh, never mind.
Okay? All right. So capital B and P refer to the base. Okay? All right, so that's the surface area of the prism, which you guys just derived with me. Let's go ahead and find the surface area of this. Okay, what shape is this, first of all? It's a triangular prism. Okay? So the first thing you have to do is identify the base. In this case, this is the base. Okay? If you need to, you could. So let me copy that base down here. Since it's a right triangle, that kind of helps us out, because if it's a right triangle, one of the legs is the base, the other leg is the height. Okay? So base area is 9 times 8 divided by 2, right? Which is equal to 36. But now, for the perimeter, we do need to do the Pythagorean theorem, right? So let's call this C. So 9 squared plus 8 squared is equal to C squared, right? This is 81 plus 64, it's 145. C squared is 145. So C is the square root of, huh?
About 12.
Right, let's leave it as the square root of 145 for now, because we're going to round later on anyway. We can just put it in the calculator in one shot. So the surface area is 2b plus the perimeter times the height. This is 2 times 36 plus, what's the perimeter of the base? 9 plus 8 plus root 145. And then what's the height? 5, right? Height is the 5 because it's the distance between the two bases, all right? Times 5. And you plug that into your calculator and you get 217.21 inches squared. Okay? All right. Take a look at this one. What shape is this? What's the base? What shape is the base? A pentagon. So, first we need to find the area of the pentagon. This is a regular pentagon. All we have is that one side given. So guess what we do? Find the apothem and blah, 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 blah. So now all of that you did is going to be step 1 of this problem. Right? Okay. So, this is the apothem. We do this. So if this is a pentagon, 360 divided by 5 is 72, which means this is 36. All right. So to find the apothem, this is 7. I have the angle, the opposite, and the adjacent. So tangent of 36 is 7 over A. A is 7 over tangent of 36, 9.63. Okay, now, what's the base area? It's the perimeter times the apothem over 2. So, what was the perimeter? 14 times 5 times the apothem, all over 2. So that's the base area. This is what you took a test on. This was one of the problems. And now it's just step 1. Okay? Now, to find the surface area, it's 2 times the base area plus the perimeter of the base times what's the height of the prism? 8. It's this. Okay? So 2b plus ph. This is 2 times b plus the perimeter is 70 times 8. It's 1234.43. A cute little number. Okay? All right. Next. Oh, what shape is this one? It's a hexagon. That means 360 over 6 is 60. So when I do this, it's 30. Oh, look, it's a 30, 60, 90 triangle, right? Okay, so that's too small. Let me just write one over here. Let me draw a bigger one here. Okay? So this is 30, and this is 2. So 2 root 3, 4, right? Yes? Okay, so the apothem is 2 root 3. All right, so the base area is the apothem times the perimeter. How much is the perimeter? 24. All over 2. And this is equal to 24 root 3. Let's put it all into the formula, and then so we only plug it into the calculator one time. Okay, so surface area is 2b plus p times h. 2 times 24 root 3 plus the perimeter, right? We keep using the same perimeter, right? It's 24 times, if this is the base and that's the base, the distance in between is 15. Okay? So if you wanted this in exact form, it would be 48 root 3 plus 360, or 443.14 centimeters squared. Okay. I'm going to give you guys like 2 minutes to do this one on your own. Same situation. This is the base. Okay. You're going to find the apothem. So go ahead and do that. Okay, let's do it an easier way. Since we have this given as a 4, this is the base of the triangle, right? The 5. And this would be the height, correct? So if this is 2.5, you can also do Pythagorean theorem to find the height. So 2.5 squared plus 4 squared is, plus h squared is equal to 4 squared. Okay, 2.5 squared plus h squared is equal to 4 squared. Right? And So what do we get for h here when you take a square root? And in decimal, how much is that? 3.1225.
Yeah.
Good. Okay, so the base area then is half times base times height, right? So 5 times 3.1225 all over 2. This is 7.81. All right. Go ahead and take that and put it into the surface area formula.
Oh, I forgot the height is 9.5. I used the height for the thing.
Yeah.
9.5.
Huh?
So I don't know.
Usually I follow your work when it comes to that stuff, and then if it's okay, it's okay. All right? It depends on like where you round it, probably. Okay. So let's move on to cylinders. So like this bottle, if this was flat on top, would be a cylinder, right? Again, you've got a base which is circular this time, right? And then the lateral surface is just what? It's like there are no edges on the lateral surface, right? Yes. Yes. So if you had, okay, so look, if this was your cylinder, right? Do you see how you have a base on top and a base on the bottom? And now look at this lateral side, right? If I unravel this, what happens to it? Everybody looking up here? Harrison, look up here, right? If I were to unravel this, it is a rectangle, right? So to find the area of this lateral surface, it's actually a rectangle that you have to find the area of when you unravel it. So it's height times base. Well, what is the base of that? Oh, look, it's the circumference of that circle underneath. Okay? So that's how cylinders work. So if you look up here, right? Again, you've got a base and a base. You've got the height or the altitude. It's the distance between the two bases. And we just talked about lateral area. So here is another picture, right, of how it looks. If this cylinder is unraveled, then you've got two circular bases and then a rectangle. And the rectangle has area of 2 pi r times h, circumference times h. Okay, so 2 ways to memorize the formula. Again, but it's the same thing, right? 2b plus, instead of perimeter, it's the circumference times the height. So 2 pi r squared plus 2 pi r h. Okay, so let's take a look at this. This is a cylinder. Here's a circle. The radius is 8.3. So the base area is pi r squared. So surface area is 2 pi r squared plus 2 pi r h. Right? And if you just memorize the formula, which you're going to have to, if you just say it out loud to yourself, and then just write it down, 2 pi r squared plus 2 pi r h, right? And it's usually very straightforward. This becomes 777.04 square feet. Okay, I will give you a minute to do B, please. Go ahead. The diameter is 6, meaning the radius is 3, right? So surface area is 2 pi r squared plus 2 pi r h. And then I would just plug the whole thing into the calculator like that, and we get 339.29. Okay? So, you know what? If you simplify this, what do you get? This is 9 times 2, 18 pi, right? Plus 45 times 2 is 90 pi. which is equal to 108 pi. And if you wanted the answer in exact form, that's what it would be, right? Centimeters squared. Okay. Take a look at the next one. Now we're given the surface area. It's 96 pi square centimeters. Can you please add the square for the unit over there? And the height is 8 centimeters. We need to find the radius. Okay. Always write the formula first. 2 pi r squared plus 2 pi rh. 96 pi is equal to 2 pi r squared plus 2 pi r times 8. Now, take a look at what you can do. There's a 2 pi here, there's a 2 pi here. You can divide each term by 2 pi. Okay, I say you can divide, but what I really mean to say is you need to divide each of those by 2 pi. Okay? So these 2 pi's cancel, these 2 pi's cancel. Here, the pi's go away, and 96 over 2 is 48, equals r squared plus 8. Most common mistake here is when your writing isn't neat, right, and it's all over the place, then you're canceling things out. I'm sorry, 8r. Sorry. That's exactly what I was going to say. You're canceling things out and you forget that there are things left over there. Okay? Oh, and now look at us. We've got a quadratic equation on our hands. Bring everything to the same side. So minus 48. And now you're gonna factor.
And it comes back.
Did it ever leave? No. So, two numbers that multiply to negative 48, but add to 8. What do you all think? What are the factors of 48? 12 and 4 it is. Plus 12 minus 4. So, r plus 12 equals 0. R equals negative 12 doesn't work, but r equals 4 certainly does work. So, it's 4 centimeters. Okay? Yay!